Hi friends, can you tell me what is common to all the motions shown here? That's right, they are all motion in a straight line. This is also known as rectilinear motion and is going to be the topic of this video. There are a lot of concepts in this chapter like distance, displacement, speed, velocity, average velocity, instantaneous velocity and so on. Don't worry, I'm going to make all these concepts crystal clear for you. So let's get this topic into motion. When is an object in motion? When the position of the object keeps changing. So we can say motion is the change in position of an object with time. Now there can be many different types of motion, like motion along a straight line, like a moving train, a curvilinear motion, like a car taking a turn, circular motion, like the earth going around the sun, oscillatory motion, like a swing. So there are many different kinds of motion. But in this video, we will focus on the simplest type of motion, which is motion in a straight line, also known as rectilinear motion. We will also make an assumption or simplification where we will treat all the objects as small in size or point size objects. So whether it is you who's moving or a car or a train, we will treat all the moving objects as tiny in size, or we can call that point size objects. If you want to describe the motion of an object, you can measure its distance from a reference point. For example, a car is 10 meters away from you right now. After 5 seconds, it is at a distance of 20 meters. After 10 seconds, let's say it is at a distance of 35 meters from you, and so on. Now, is this car moving? Yes, because its distance from you is changing with time. The reference point is like the origin of the coordinate axis, and we can measure the distances along the x-axis. So to describe the motion of an object, you need two things: a coordinate system and a clock to measure the time. Now this coordinate system with a clock is called a frame of reference in physics. For motion in a straight line, you don't need the entire coordinate plane to describe the motion. We only need the x-axis to describe the motion of the body. But you might be thinking, what if the car is moving along the y-axis? What will you do then? Very simple. Just rotate the axis like this so that the x-axis lies in the line of the moving car. Similarly, if the car is moving like this, we don't need the x and y coordinate to describe the motion. Again, we are just going to rotate the axis so that the x-axis coincides with the motion of the car. So the x values will be enough to describe the motion of the body. So remember, for motion in a straight line, the x-axis is enough to describe the motion of the moving body. Let's say a car is moving in a straight line along the x-axis as shown here. The car moves from O to P and then from P to Q. What is the distance traveled by the car? Remember, distance is the total length of the path traveled. As you can see in the picture here, the distance from O to P is 300 meters and P to Q is 100 meters. So the total distance is 300 plus 100, 400 meters. Distance is a scalar quantity. We only care about the magnitude, which means the value. The value is 400 meters in this case. We don't care about the direction. So in distance, we do not specify the direction. That is why, remember, distance is a scalar quantity. If we want to specify position with direction, we use displacement. Displacement is a vector quantity. It has both magnitude and direction. You might have learned that displacement is defined as the shortest distance from the initial to the final position. Shortest distance is found by simply drawing a straight line from the initial to the final position, since straight line is the shortest possible path. Now when motion is in a straight line, displacement can be found by finding the difference in the x coordinates of the final position and the initial position. So displacement can be denoted as delta x equal to x2 minus x1, where x2 is the final x coordinate and x1 is the initial x coordinate of the moving body. And delta x represents the change in position, because delta means change. When the car moves from O to P, the displacement delta x is calculated as x2 minus x1, which is 300 meters minus 0 meters. So the answer is 300 meters. When the car moves from P to Q, again the displacement delta x is x2 minus x1, which is 200 meters minus 300 meters. So always remember to subtract the final position, the final value, minus the initial position. So here the answer is minus 100 meters. But why do we have a negative sign here? Because the car is moving towards the negative x-axis. A positive displacement indicates that the object is moving along the positive x-axis, and a negative displacement indicates that the object is moving along the negative x-axis. So the sign of the displacement, positive or negative, gives us the direction of displacement. So for motion in a straight line, we don't need a vector notation since the movement is only along the x-axis. So the x value and the sign is enough to describe the displacement. We don't have to say north, south or anything like that. Just the positive and negative value tells us the direction. Now if we want to calculate the overall displacement from O to Q, then we can simply add up the two numbers, the displacement from O to P and the displacement from P to Q. But we should add the numbers with the correct sign because it is a vector quantity. So the overall displacement here is going to be 300 meters plus minus 100 meters, not just 100 meters. You have to put in the negative sign. So the answer is going to be 200 meters. And as you can see, the car moved from O to Q by 200 meters to the right, which is along the positive x-axis. So the sign also gives you the direction. So remember, displacement is a vector quantity. It has both value and direction was shown with the positive and negative sign here. Now let's say the car goes from O to P and then comes back to O. What is the distance traveled and the displacement of the car in this case? The total distance traveled is 300 meters plus 300 meters because it goes from O to P and back to O. So the total is 600 meters. Distance traveled is 600 meters here. Now what is the displacement? That's right, the displacement is 0 because the car has come back to the initial position. So since the car is back to its initial position, it has 0 displacement. It has not moved from it. So for example, if you go to your friend's place and come back to your home, your displacement is going to be 0 because you are back at your initial position. So remember, displacement of a moving body could be 0. We have discussed about a moving object and how we can use distance and displacement to describe the change in its position with time. Now how can we measure how fast the object is moving? For this, we can use the concept of speed. When a car is moving very fast, we say that it is moving with a high speed. Speed is defined in physics as the rate of change of distance. You might have heard of the speed formula. Speed is distance divided by time. Now if two cars travel the same distance, but the car that travels in less time moves with higher speed. What is the SI unit of speed? Very simple. It's distance divided by time. So the SI unit will be meter divided by second or meter per second. For example, let's say a car travels 10 meters in 2 seconds. What is the speed of the car? 10 meters divided by 2 seconds, so it is 5 meters per second. In speed, we do not specify the direction, just the value of the speed. So speed is a scalar quantity. It has only magnitude and no direction. And it's also easy to remember. S for speed, S for scalar. When you travel by a bike or car, if there is a lot of traffic, your vehicle moves slowly. And if the road is clear, then you're moving very fast. And if you are at a red light, the vehicle stops and your speed becomes 0. So the speed of the vehicle keeps changing all the time, right? The speed does not remain constant throughout. So how can we describe the speed of the vehicle if we have to tell someone what is the speed? Here we can use average speed. We discussed that speed is distance divided by time. In average speed, you measure the total distance traveled divided by the total time. So average speed is like the average over the entire journey, and that's how you can specify the average speed of your vehicle. For a moving body, if we give the speed and the direction in which it is moving, then we call it velocity. For example, we can say the velocity of a car is 5 meters per second towards the north. Here both the value, the magnitude, 5 meters per second and the direction north are specified. So we can say velocity is speed with direction. So velocity is a vector quantity. Again, easy to remember. V for velocity, V for vector. Speed was defined as rate of change of distance. Similarly, velocity, which is a vector quantity, is defined as rate of change of displacement. Formula of velocity is displacement divided by time, or change of displacement divided by time. We can denote it as the velocity v is x2 minus x1 divided by t2 minus t1, which is represented as delta x by delta t. Delta x represents the change in displacement, which is x2 minus x1, the final displacement minus the initial displacement, and delta t is the change in time, t2 minus t1. Now you can see that there is a dash or an arrow above the v, which represents that velocity is a vector quantity. It has a direction. And just like we discussed about average speed, similarly we can specify the average velocity for the entire journey. And what will that be? Again, simple. The formula is going to be the total displacement of the moving body divided by the total time. So that's the formula of average velocity. Let's go back to our car example, where the car traveled from O to P and then back to Q. Let's say it took 100 seconds for this entire journey. Can you find the average speed and the average velocity of the car? It's really simple. Just use the formulas. Average speed is total distance divided by the total time. The total distance here we calculated was 400 meters and the total time was 100 seconds. So average speed is going to be 400 divided by 100, which is 4 meters per second. Now how do you find the average velocity? Again, use the formula total displacement divided by total time. As we found, the total displacement of the car was 200 meters and the total time here is 100 seconds. So average velocity is going to be 2 meters per second. What is the direction of the velocity here? As it is a positive number, the car is moving along the positive x-axis. So we know that is our direction from the value. Now, why is average speed greater than the average velocity? Think. It's because distance is always greater than displacement. Why? Because distance is the total length of the path traveled, whereas displacement is the shortest path from the initial to the final position. So displacement will always be smaller than distance. And this is why average speed will always be greater than or equal to the average velocity. Now what will be the average velocity of the car if it comes back to O? That's right, average velocity is going to be 0. Since the car has come back to its initial position, the total displacement is 0. So the average velocity of the car will be 0 in that case. Do you know how we can measure the speed of a car? What is the instrument used to find the speed? That's right, it's called the speedometer. You must have seen it in all the vehicles like a bike, car and buses. They all have a speedometer. Now, does the speedometer measure the average speed of the car? That is, does it give us the speed over the entire journey? No, it gives us the speed at that instant, at that moment in time. And that is why it is called instantaneous speed. For example, if the car stops at a red light, then the speedometer shows 0 speed. When the car moves slowly, it might show something like 10 kilometers per hour. But let's say you're moving really fast, It shows maybe 60, 70 kilometers per hour. As the speed of the car changes, it keeps showing different values. Do you know how the speedometer is calculating the instantaneous speed? It calculates the distance traveled by the car in a very short interval of time. For example, how much the car travels in the next, let's say, 0.1 second. So let's say the car travels 0.5 meters in 0.1 second. So the instantaneous speed will be 0.5 meters divided by 0.1 second, which is 5 meter per second. Now you can make the time interval even smaller and smaller, like 0.01 second or 0.001 second and so on. And the instantaneous speed will be more accurate. Just like we have instantaneous speed, we can also define instantaneous velocity, v, as the displacement in a very short interval of time. The velocity formula is delta x divided by delta t, change in displacement by change in time. For instantaneous velocity, we want the time interval to be very, very small. So we write it as limit delta t tending to 0. This notation means that delta t is not 0, but it's a very, very small number. That's why we are saying tending to 0, moving towards 0. So very tiny time interval. And when you have this limit delta t tending to 0, in the language of calculus, we write this as velocity v is dx by dt. So the instantaneous velocity will be dx by dt. Till now we have discussed speed and velocity using formulas. Now let's look at it from a graphical perspective. If we have a distance time graph where time is along the x-axis and distance is along the y-axis, how can you calculate the speed of the body from this graph here? Remember, from a graph we can do three things: read values, calculate the slope and find the area under the graph. So what do you think is needed to find the speed from a distance time graph? That's right, you need to calculate the slope of this graph. Why? Because slope of a graph is delta y by delta x. Remember, change in y by change in x values. That is going to be here delta x divided by delta t, which means change of distance divided by change in time. And we know that change in distance by time is the speed of the body. So what you need to do is calculate the slope of this distance time graph to get the speed of the body. Now for example, in this graph, if the line is flat like this, then you know that slope of the graph is 0. The line is flat, which means that the speed of the body is 0. And as you can see here, the distance x of the body is remaining constant, so the speed of the body is 0. Now let's say you have a distance time graph like this, where the graph is a straight line. Now if you calculate the slope of the graph using delta x by delta t, that is change in distance by change in time, it doesn't matter whichever points you consider on this graph, the slope will come out constant throughout. It will be same throughout. And slope is constant because it is a straight line. So we can say that speed of such a body which has a graph like this, the speed of the body is constant, because remember, slope is a straight line. Now let's say the distance time graph of a moving body is curved like this. Now is the speed constant? The answer is no. Because if you consider different points on this graph and you calculate the slope, that is delta x by delta t, change in distance by change in time, you will see that you are getting different values. So clearly the speed of the body is not constant. Now if the time values are far apart, let's say you take time from 0 to 10 seconds and you calculate the speed using delta x by delta t, then basically you will get the average speed from 0 to 10 seconds. So how do we calculate the instantaneous speed from such a graph? Remember guys, instantaneous speed is the speed at a particular instant. So as we discussed, to calculate the instantaneous speed, the time interval delta t should be very small. And to make the time interval very small, we can bring t1 and t2 really close to each other. So the line that touches the graph at the point is going to be a tangent to the graph, right? And the slope of this tangent is the instantaneous speed. So that's how you will get the instantaneous speed. the slope of the tangent at a given point. And at different points in this curved graph, the slopes of the tangent will be different. So what can we conclude, guys? That's right, that the instantaneous speed of the body keeps changing, which means sometimes the body is going faster, sometimes it's going slower. Its instantaneous speed is continuously changing. It does not have a constant speed, as you can see from the graph here. We looked at average speed and instantaneous speed from a distance time graph. Similarly, you can calculate the average velocity and instantaneous velocity from a displacement time graph. Velocity, remember, is a vector quantity. So we need a displacement time graph for it. The slope of the graph at any point will give you the instantaneous velocity at that point, just like we got instantaneous speed, right? So graphs are a powerful visual tool for understanding the type of motion of a body. For example, if the displacement time graph is a straight line like this, we know the body is stationary. The displacement is constant, so the velocity of the body is going to be 0. But if the displacement time graph is a straight line like this, then what do we know? We can see that the slope is constant, guys. So the velocity of the body is going to be constant. And a curved velocity time graph like this will tell you that the instantaneous velocity of the body is constantly changing, because the slope of this graph, as you can see, is going to be continuously changing. This means that the body is not in uniform motion, because remember, for a body to be in uniform motion, the velocity should be same throughout, constant. But you can see here the velocity is constantly changing, so the body is in non-uniform motion, right? Because in uniform motion, what did you have? You have to travel equal distances in equal intervals of time. In non-uniform motion, it means you're having unequal distances or unequal displacements in equal intervals of time. So clearly this body, which is having a changing velocity, you can remember, is clearly in non-uniform motion, because non-uniform motion means velocity is constantly changing. Friends, I hope you enjoyed this video and these motion concepts are crystal clear to you now. If you're interested in more videos like this, or you'd like to join our regular live classes, do check out our website manochaacademy.com and our Android app Manocha Academy. To make it easy, I'll put the links below. We have courses on physics, chemistry, biology, maths, coding and artificial intelligence. So what are you going to get in these courses? We have live classes, concept videos, quizzes, questions, mock tests and revision notes. So they'll be perfect for your exam preparation. So do check out our courses. Links are given below and please do share it with your friends. And don't forget to hit the like button for this video and make sure you have subscribed to our channel, because when you hit that like button and subscribe button, it costs you nothing, but it really motivates us to make more videos for you. So do share out our channel with your friends and stay connected with Manocha Academy and keep on learning.